language of algebra. Remember all about algebra? Algebra is all that stuff that has all the letters in it. And algebra is like its own language, and we can use it to solve problems. Now I want to put all my updates on here. There we go. So we have an expression here on the top of the page in the very big letters there. Here is an expression, 3x plus 4y minus 7z plus 5. That's what we call an expression. It's lots of little, we call terms, separated by pluses or minus signs. So I'm going to quickly go through a whole bunch of vocabulary here that you should be aware of. The first word that you need to know is the word pronumeral. So when I say the word pronumeral, it's a very fancy mathematical word that just means letters. So it's talking about the letters that are in this thing here, all the letters that you can see. So X is a pronumeral, Y is a pronumeral. Then the next one, variable. Now, the pronumeral that is in there, the reason we put letters in there, Noah, the reason we put letters in there is because it could change. We could change the value of that letter depending on what the situation was. Sometimes X could be 2, sometimes X could be 10, sometimes it could be a -5, whatever. And that's why it is called a variable, because it could represent more than one number, okay? Next, expression. An expression is made up of numbers and letters, which is our pronumerals, remember, joined together with our add, subtract, multiply, and divide. Normally, you'll be able to identify it by looking at an expression like this one here and going, oh, look, there's a term because there's a plus sign. There's my next term and there's another sign. There's my next term and there's my last term. So you can see there's 4 terms in there that are separated by those pluses and minus signs. Okay, so that's the word term and expression. I kind of covered both of those there. The expression is the whole thing, and the term are the little parts that are in it, separated by the pluses and minus. Here is a new word. Oh, actually, no, we talked about this one last year, I'm pretty sure. Coefficient. Do you remember that one? Yeah. You do, good. So coefficient means, computer's still messing up. Coefficient means the number in front of, it deleted everything.
It went back to what?
It went back, it deleted. Don't do that. Mr. Appel, see, look. Oh, he stole it.
He's showing us this. Thank you, Mr. Appel.
Mr. Appel, you're doing the wrong screen, Mr. Appel. I told you it was him messing me up. No, Mr. Appel. This is my room. Me. It will be me. I'll fight you for it. My screen.
Miss.
Yes. Yep. It's my screen.
How come that happened?
Yeah, I don't know. Oh, the teachers can take controls of the screens from other rooms. He was in here last period, so he's probably just connected to the same room again and forgot that he was actually in a different room.
How can he still see what he's doing?
He wouldn't, which he hopefully would have realized pretty quick that he had the wrong room. Anyway, let's hope he doesn't do it again. Coefficient is the number in front of the letter. So the 3 is the coefficient of the X. Okay, just the number. We only want the number that's in front of it. So I say, what is the coefficient of Y? What's the coefficient of Y? 4. Excellent. Okay, next we have a constant. The constant term is the one that doesn't have any letters. So back up here to my expression. Which one doesn't have any letters on it?
5.
The 5s. That's the constant term. And what's next? Sum. If I hear the word sum, it just means that we want to plus some things together. Difference means we're going to subtract or minus. Product, multiply, times, they all mean the same thing. Quotient means to divide, and to square something means to times it by itself. And you'll often see it written like this, a squared. Okay? All right. So now that we know all the words, we've revised all the words, hopefully I'll be able to write on my screen again the answer to these examples here. Let's have a look. I'm giving you an expression, 4a plus b minus 12c plus 5. Very similar to the last one we just looked at. Using that expression, it says list the individual terms Remember, the terms are the parts that are separated by the plus and minus signs. So my first term is going to be the 4a. Okay, I'm just going to use a comma as a list. I'm listing off what my terms are. So 4a is my first term. The next one's going to be the b. The next one's going to be a minus 12. If it's a negative term, we need to include that minus sign, okay? And the 5 on the end, it is also a term. It's just a special one because it's the constant term, remember. Part B, state the coefficients of A, B, C, and D. What does that word coefficient mean? Oh, I thought you were going to put your hand up, Ethan. I thought you knew. Yep.
Is it the letter in front of it?
Number. The number in front of that letter. So if I say, what is the coefficient of A, I want to know the number in front of the A. What is it?
4.
4. All right, that one's a 4. Coefficient of B.
Nothing.
If there's nothing there, remember our lovely little tricks we do for algebra? If there is no number in front of a letter, it means it's a 1. Okay, so trying to trick you there, that's a 1. What is the coefficient of the C?
12.
Don't forget, when there's a minus sign, you have to remember to include that minus sign, minus 12. And what is the coefficient of D?
Someone in 8B left this before.
Anyone belong to this?
8B?
No, we're all spread right. Sorry. Coefficient of D.
5.
Can anyone see a D?
No, so it'll be 0.
So it'd be 0 because there actually isn't one. So there's no D term there at all. So we're going to put a 0. C is what you were trying to do, Ethan. The constant term. What is the constant term? That's that 5 on the end that doesn't have any letters. Okay, so that's a bit of practice identifying our terms and our constant terms. Now, question 2. Write an expression for each of the following. So you have to write your own one. You know, your 5x plus 2y. We're going to write your own expression. You don't have to solve it. You just have to write down what the expression is. So this one says, what is the sum? What does the word sum mean? I want to add something. So if you want to, you can highlight that. You know, that means I'm going to be plussing. It's going to be a sum of 3 and k. Okay, I just want to sum or add 3 and k. So I'm just going to go 3 plus k. I have summed 3 and k. That's an expression. As I said, we're not solving it. We just need to be able to write that expression down. Okay, part B. Let's do this again. 5 is added. So that word added means we're going to have to do a plus sign in there somewhere. To half of k. All right, how can I write half of k? Yes, Cash. Yeah, there's actually 2 ways you can write it. You can go half k. Can anyone think of a second way to write half k? Ooh, yes. What's your name?
Riley.
Oh, you're a different. You're not Riley Tonelli. I'm like, no, I can't tell between the marks. Riley, thank you, Riley. What was another way to write it?
0.5k.
Yes, we don't like to go to decimals, but good try. It does work technically, but we don't prefer to go to decimals. Do you remember that half of something is the same as dividing it by 2? So that's another way to write it as well. So either one of those would be acceptable. The k over 2 is probably the more common what you're going to see. We prefer to write them as that kind of fraction. So you'll hopefully get used to seeing them like that. Okay, so that's our half k. And 5 is added, so we just want to add 5 to that. So either one, I'm writing them both down, I'm putting an or in the middle. So either one of those options would be okay. You could even put the 5 at the front. You could have gone 5 plus k over 2, and that's the same as well. All right? The only thing you have to be careful of, if you're subtracting, it is important the way that you subtract things, okay? Because 7 minus 2 is different to 2 minus 7, isn't it? Okay, subtracting, you have to be careful which order you write them in. But adding is okay. All right, question 3. This one comes out of your textbook. A mobile phone call costs 20 cents connection fee and then 50 cents per minute. We want to write some expressions here. So write an expression if we're working in cents, and both of those numbers were in cents. If I'm going to make a call that lasts for t minutes, t could be 2 minutes, it could be 5 minutes, it could be 30 minutes. I don't know. That's my variable, right? So it costs 20 cents just to connect. Okay, so straight away, I'm paying 20 cents. Then I have to pay 50 cents. I'm going to have to add to that, because you got 20 cents plus I'm going to have to add it costs me 50 cents for every minute. What expression am I going to write for 50 cents for a minute? It's going to involve that t, because remember, t is my number of minutes. Anyone want to have a go?
T50.
Yeah. But we put the number first. 50t. Because if it was 2 minutes, we'd go 2 times 50 or 50 times 2. If it was 10 minutes, we'd go 50 times 10. Remember, when the 50 and the t are next to each other does mean times. Algebra, things next to each other means times, okay? So it's 20 cents plus 50 cents for every minute after that, okay? That's my expression. It's a bit of this is a tricky one here. Let's try part B. Write an expression for the total cost in dollars. Okay, so that's the only change. I still want the exact same 20 cents per connection, 50 cents per minute, but I want it in dollars instead of in cents. There is 2 ways you could do this. Does anyone have any ideas? Nope, no ideas. Well, the expression that I just had was what it is in cents, right? How do you turn dollars into cents? Careful. Which way? Or did I say it the wrong way? I said it the wrong way. How do you turn cents into dollars?
Divided by 2.
Divided by, not 2. How many cents are in a dollar?
100.
100. So if I already know, if this is what I've got in cents, I've got to divide that by 100 if I want to know what it is in dollars, right? So I can just go, let's just divide all that by 100. It's in dollars. Option number 2. I could have changed my 20 cents and my 50 cents into dollars before I'd written my expression. So 20 cents, how do you write 20 cents in dollars?
0.2.
$0.2 in 20 cents. Plus, I'm basically just rewriting this expression here, but I'm just changing it into dollars. What about the 50 cents? So plus 0.5t. Okay, and part C. Now this is a tricky one, okay? Write an expression for the total cost in dollars if it lasts for t hours. Does that mess with your brain? We want the cost in dollars, and the difference here is that we've now got our time in hours instead of in minutes. Okay, because before we were talking about t minutes, right? So this is the extra catch with this one. So let's take this expression here, because this is in dollars, right? That one's already in dollars, so that solves my dollars problem. It's going to be $0.2 and $0.5 for every t. The only difference is here, before t was in minutes. If t is now in hours, how many minutes are in an hour? 60. So I would have an extra 60t there. Because if I say 2 hours, that's actually 120 minutes. I've got to times that by an extra 60 in there, right? I told this was a tricky one. And that's actually my expression. We can tidy it up a little bit, because what is 0.5 times 60? Or half of 60 is what that means. Yeah. So 0.2 plus 30t. So you can put a bit of a star next to that question. Actually, probably the whole question. That whole question is definitely a bit of a challenge, okay? Most of your questions will be in the easier time. So that is the end of my explanation. All of the questions that you need to do follow straight afterwards. Okay, so I'm going to turn off my video